say that you're technically supposed to fill something out, this attachment thing, and it was due last week. There's
Has a little rubric here.
Drew, when did we get the feedback from him?
Like yesterday.
Okay. So I don't know how we can, turn in data that's collected until we have feedback. So.
yeah.
All right. So we'll just move forward. Annie, let us know what you hear back from the professor.
Okay.
And, yeah. And does somebody want to turn in something? And I guess I'll turn it in when I turn in to describe the data.
Yeah, see, and so they've got a Word document that you download, and you just put in the name of the group members, you state your research question, say like a short summary of the data, and then you attach the data. So it's fairly simple for collect the data.
Yeah, except we have to have somebody has to have all the data in order to do it.
Yeah, and then describe the data is probably just a little more involved, descriptive than that.
Oh yeah, no, I know what I need to do. I need to put some charts together, and I'm fine with describe the data. But I could compile those two pretty easily. Well, all right. I didn't think we were supposed to turn anything in for collected data for some reason. Sorry. All right. How was the lesson?
Okay.
Yeah, I thought so. Okay. Any questions on what we did? On the lesson, part 1, part 2.
Tuck yourself in.
Did everybody do part 2?
Yeah, I went through it.
Yeah.
I didn't know how, like when you put all the information, I don't know where to get the y-intercept or the slope. I really didn't know.
Okay, it's when you've got the line. Oh, you mean like on the
Excel thing?
spreadsheet? Okay, hold on. Okay, for some reason, I thought this was okay, so on the t-test for linear regression, is that what you're looking at, Annie? Or sorry, Bernice?
Yeah.
Okay. So if you look under, like in the middle, you'll see confidence level. You see that?
Yeah.
Model summary. Okay, the box underneath on the left-hand side says model, and then it says y-intercept underneath, and then it says slope. Okay, so right next to the y-intercept is your y-intercept, and right next to the slope box is your slope.
Oh.
Okay?
Okay.
Okay, so do we want to go over part 2 together then?
Yeah, we can go through it real quick.
Okay. I don't have the questions up right now. I've got my answers. Does anybody want to ask the questions and we can go over it that way?
I can read the questions.
Okay, thanks.
Number 1, what is the explanatory variable? I've got head length.
Okay, yes. It's the x value, yeah.
Yeah. Second question, what is the response variable? That's the body length.
Or the y value, yep.
And then number 3, you just create a scatter plot.
Right.
Number 4, use the software to compute the value of the y-intercept. So from the Excel sheet, you can find that. And I got negative 69.369.
Yes. Keep going. I have to step away for 1 second.
Okay. Number 5 is using Excel to find the slope. And I got 7.4. And then number 6, you put that into the equation. So it would be y equals 69.369 plus 7.4x. And number 7, you do the scatter plot with the regression line on it. So you just kind of copy and paste that. And number 8, you plug in, or no, you look at the data file because it's the head length of 51. So you're going to find 51 on the data file or on the Excel. And you find what 51 corresponds to, and I got 343.
43.
Mm-hmm. And then number 9, they want you to actually plug in 51 to the equation. And when I did that, I got 446.769.
what?
I'm not sure.
It's 446.769.
Where, on what number?
Number 9.
I got 308.
Yeah, I think that's more accurate.
I got way off. How did I get mine? Let me.
Would you say 400 and something?
At 446. Let's
Yeah,
see.
you added.
Okay, and you said the y-intercept was negative 69.69, right?
Yeah.
Did you say negative 69.369 was the y-intercept?
Oh,
It
see,
needs
I
to
don't
be-
have it negative.
Yeah, that's why.
Oh, that's what's going on right there.
Okay, that would explain it. Okay. Okay, now I got 308.031.
Yes.
And then number 10, why are the values different? And what I kind of put was that number 9 is kind of the predicted measurement, whereas number 8 is an actual number.
Yeah. The actual points are not necessarily even on the regression line.
Yeah, and you'll get that because it's not a complete straight line. It's going to be around the line as much as possible. That's why it's the line of regression, is they kind of hover around the line.
Right. I mean, sometimes you'll have points on the line, but yeah, it's not. It's kind of the exception to the rule.
Yes.
Okay. Any questions on that? Thanks.
No. No. Okay.
Okay. All right. Shall we start the quiz?
Mm-hmm.
Okay, let's do it. All right, number 3. What's the y-intercept?
2.0.
Yeah.
Yep.
What is the slope?
1.5.
Yeah. Okay, given the linear regression equation y equals negative 3.0 times 0.25x, what is the predicted value of y when x equals 16?
I got 1.0.
But I got 2. Okay, make a scatter plot. The math self-efficacy data.
I don't like any of these answers.
Yeah, it's not hot. It's not banana shaped. That's for sure.
Yeah, it's not.
I think it's hot dog shape.
Yeah, I think it might be hot dog shaped too. It doesn't look hamburger shaped. It's not spread out enough. What do you guys think?
That's what I would say.
Yeah, I think it's the closest. I don't know.
Yeah, no, I understand. Yeah. Based on the shape of the scatter plot you produced in question 6, what can you say about the appropriate of using simple linear regression to model these data? Let's see what the R value is. 0.728. You could use it. If simple iteration is used for these data, the results will not be reliable. Simple iteration is appropriate for these data. That's a hard one, too. I mean, I don't feel like they did a great job of teaching us what a weak R value was.
No, I don't even remember. I'd have to go back to my notes from last week.
Yeah, but even then, they didn't really say, hey, if you get this, if you get below this, it's not good.
Could be either way.
Let's see. This is funny. I'm trying to look it up, and it's like statistics 2. I mean, I know a strong value is the closer you are to 1, the better, right? But
Yeah.
correlation greater than 0.8 is generally described as strong, whereas a correlation less than 0.5 is generally described as weak. Not
So
sure.
it's moderate.
Yeah. So, but what do you think that means then? Do we go with it?
I would say yeah, just because technically it is closer to 1 than 0, because it is over 0.5. And didn't they say something about moderate's not really something they're going to teach in this class? If you get more into the statistics, then they'll teach more about moderate.
Yeah. I don't know. I don't think it would be A. I do think it's either B or C, but I'm just not sure. I can't, I mean, I don't know how reliable. I mean, you look at that scatter plot, and you're not going to get data results that are real close. I wouldn't want to do a regression on this one. I mean, but all right. I think you're right, though, Annie. I think it's the closest thing.
Okay.
Okay, how many observations are in the math efficacy data?
This is just asking how many values, right?
Yeah. $139.
That's what I put.
Yeah, that seems about right.
Okay, let's see. Answer these questions. What is the y-intercept? Your answer should be exact. Okay. 1.296.
I was thinking.
For which question?
Y-intercept.
I got 18.69.
Okay.
Is it possible? I did this at first. You have to put the confidence rating in the explanatory and the score in the response variable.
Okay, I'm still not seeing. What are you saying?
What?
Unless you put in different values than me, doesn't make any sense.
So with the math self-efficacy, it's kind of opposite what it is on the data. You've got the confidence rating as the second column, and you have to put that in the first column.
We're not using the same thing that we were using before? Isn't this the same data? Annie, what are you saying? The X and Y need to switch?
Like when you take the math self-efficacy, when you take that data information, the second column of information goes into the first column, goes into X.
Oh. But should that have been the case for earlier? Would that make a difference?
It wouldn't have made a difference on 6 through 8. Well, I guess on number 6 it would a little bit, but
Might have made a difference on 6, huh? Okay, let's see.
when I first put it in, I copied both columns on the data.
Right. I see what you're saying. I'm glad you're here, Annie. I never would have thought to do that. But you're right. The first thing that they did was they gave themselves a confidence rating, right?
Mm-hmm.
We're trying to see if confidence rating is predicting scores. Isn't that kind of the whole point here?
Yeah.
Okay.
I think it's dumb. They should put it on the spreadsheet the opposite way.
Or at least warn people.
Yeah.
A lot of people are going to fail this quiz if they don't. You said 18.690?
Yeah, for the y-intercept.
Yeah, that's what I want to know.
And the slope, I've got 12.695.
Yeah.
Okay.
Oh, look at that regression line. I actually think that looks better. Still like a hot dog, but I feel better. That's right.
Yeah.
Okay.
Yeah.
When x equals 4. Okay, so do you know how to do this, Bernice?
Yes, now we know.
Okay. So then 69.469, number 11.
Yes.
Yeah, 470.
94.859. Is that what you guys got?
I don't know, where do you get that answer? I don't see where that answer is.
So if the highest I can rate myself is a 6,
Okay.
then the maximum I would get is whatever Y value I get when I rate myself a 6.
Okay, so plug that in, you get 94.859.
Yeah.
Okay. That makes sense.
Okay, 13 and 14 are 1.
I'm not sure what 1314 is asking.
Well, in a simple linear regression, you can only have one independent variable and one dependent variable. They did allude to in the lesson that you could have more, but not in a simple linear regression.
Okay, so that,
Pretty
I
sure.
was thinking that was how many numbers there are, but that means one category or one dependent one.
Your X value and your Y value, right?
Okay.
You wouldn't have Z is equal to 1.5 plus 5X minus 2Y in a simple linear regression.
Okay.
All right, let's go back. All right, so number 3, 2.0.
Uh-huh.
4, 1.5.
Mm-hmm.
5, 1.0.
Mm-hmm.
6, we think it's hot dog shaped.
Yeah,
7, we think that the regression is appropriate for these data.
I think so.
Okay. 8, 139 observations.
Mm-hmm.
We want to check that for sure. I mean, I just subtracted and I could be wrong. We feel pretty good about that. Let's see. I think that's right. What is the y-intercept? 18.690.
No.
Yeah.
Number 10, 12.695.
Uh-huh.
What is the predicted value of y when x equals 4?
69.469.
The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. Okay, we got 94.859.
Yes.
And then 1 and 1.
Yes.
Okay, so I'm going to just check on 2 things real quick. So if you want to turn it, you can. So, all right, I feel really good about what you did, Annie. So thank you for telling us to switch those, because obviously x equals 4 and x equals 6 tells us x has got to be those 1 through 6 values. So we definitely did that right.
Okay.
And then the last 2, explanatory and response. I'm almost positive I'm on that too, but I just want to look real quick at the lesson, because I think that that's towards the end.
For which one, you said?
For those last 2, the independent or explanatory variable x is a variable which is not affected by what happens to the other variable. Dependent or response variable y is a variable which is affected by what happens to the other variable. For example, the correlation. The number of deaths is affected by the number of particles in the water, but not the other way around. So we assign x to represent the energy deaths. Okay, it doesn't say that exactly, but every single one of our examples had one independent and one dependent variable. And okay, here it is, I think. Okay, sometimes it is necessary to use more than one predictor, independent variable, to predict the value of a response dependent variable. For example, if we want to predict the stopping distance for a car on dry roads, we might want to use the initial speed of the car, the weight of the car, and the amount of tread on the tires to predict the distance required to stop the car. Although it is fairly straightforward to create a model and get the estimated multiple regression equation, the interpretation of the results can be a little tricky. If you need to conduct multiple regression, that is regression with several predictor variables, You may want to study the topic in depth or hire a statistician. So I feel pretty good about what we did.
Yeah, I think for simple, it makes sense.
Okay. All right. So we ready?
Yes.
Okay. I'm going ahead and doing it. It's an A.
Awesome. We got it all right.
Okay. If you guys could get that data to me like tonight, that would be great. And
Yeah.
I'll try and put something together and send it out to you guys before Saturday. So you can just take a look and say, I like this, change this, and then send it in on Saturday. And I guess I'll send in the collect the data thing as well, and just have both of those get sent in at the same time. Hopefully that'll work. I'll talk to Stephanie, but I would imagine, given that we just got feedback this week, it'll be fine to get it in by the end of the week.
Yeah.
Okay. I'll send it to you.
Okay, everybody feeling okay about it now? And Annie, do just let us know, because if he does say, no, you guys didn't have it in on time, then I'll work harder to get it in as early as possible.
Yeah.
I'm going to email him too, because I got scared when I saw my grill drop that much.
Yeah.
That was huge.
Yeah. Okay. Well, yeah, we'll do that. I imagine he'll get a lot of that kind of feedback. Has anybody seen anything posted on his page? Or posted on questions or anything like that? Are we the only group that said anything?
Possible.
I don't see anything, but also I don't know what this means, but if you go to like the class statistics,
Yeah.
it says that there's 38 students and every single grade has been 0. There's 38 that got an F. So I'm wondering if the entire class got graded 0%.
Right, it sounds like it. That makes me feel better. Terrible, I know. But that's why I'm saying I really don't, I think he's just going to grade it all at the end. And it must be that like there's an automatic grade that's entered in after so much time or something like that, don't you think?
Yeah, that's what I was saying.
Yeah, that's what I'm thinking.
Yeah.
You automatically get 0 if nothing else has been put in, by a certain time. So, okay. All right, sounds good. Thank you guys. We'll see you on Thursday.
Yes.
Thursday.
Okay, perfect. Have a good night.
You
Okay,
too.
bye.